Hi everyone, this is another question for differential band break. Almost similar to the previous cases, just listen. A differential band break as shown in figure operates on a drum of diameter 600 mm. The band is 3.2 mm by 100 mm and the coefficient of friction is 0.22. Determine least force required at the end of the operating lever when the band is subjected to stress of 55 Newton per millimeter square. Second one, the torque applied to the brake drum shaft. Then last one, is that brake is self-logging? Prove your answer. So this is the figure for this particular question. The dimensions are given in this question. The contact of the band to the drum is 300 degree. This is the 300 degree from here to here. Then the value of B1 and B2, that is given in the figure, and the value of I is also given in the figure, 225 millimeter. So we can write the given data. We can go for the solution. What is the given data? Diameter is 600 mm, theta is equal to 300 degree. So convert it into radian, 5.236 radian. Thickness is given, that is equal to 3.2 mm. Then breadth is given 100 mm. Coefficient of friction F is equal to 0.22 or mu is equal to 0.22. Value of the sigma stress is given 55 Newton per millimeter square. We have to find the minimum force. So just compare this figure with our data book figure on the page number 270, figure number F, and for the clockwise rotation and anti-clockwise rotation, the equations are given as 13.19 E and 13.19 F. Now we can go for the clockwise rotation. What is that value? The value of A is equal to 225. Just compare with our figure, and B1 is equal to 127 and B2 is equal to 38. Now taking the moment about the fulcrum, then F will become F is equal to F2 into B1 minus F1 into B2 divided by A, or E raised to mu theta is equal to 3.164. That is, we can find from the given data of our question. And in this case, if we solve this equation, we need F2 and F1. Also, B1, B2, A are given value, but F2 and F1 are not value. So we can find the value of F1 and F2 using following conditions. Bandwidth B is equal to F1 divided by H into sigma D. It is in our data book, page number 269. The width of the band is equal to B is equal to F1 divided by H into sigma D. That is in page number 269, equation number 13.18O. Take your data book and find this equation. In this equation, the value of F1 we can find using this data book, page number 269. Okay. Then the value of F1 will become 17,600 Newton. Once we calculated the value of F1, next we can find the value of F2 using F1 by F2 is equal to E raised to mu theta. It is also given in our data book, equation 13.18A, page number 267. Then if we substitute this value, the value of F2 will become 5,562.58 Newton. Then if we substitute these values in this equation, that is Ft is equal to F1 minus F2, then what is the value of F? If we substitute these values in this previous equation, then the value of F is equal to 167.32 Newton. F1 and F2 in the previous equation. Now go for the counterclockwise direction. For the counterclockwise direction, moment equation become Fa plus F2 into B2 minus F1 into B1 is equal to 0. Then F is equal to F1 into B1 minus F2 into B2 divided by A. That is equal to 8,994.76 Newton. All the values we calculated in the previous conditions. So which one is lesser? For the clockwise direction, that value will become 167, but for the counterclockwise direction, that will become 8,994. So they are asking about the minimum value. What is that minimum value? That is equal to 167.32. Thus we will get the minimum value for the force. Next, we need to find the value of torque applied. That we already calculated the value of Ft. Ft is equal to F1 minus F2. F1 and F2 are known parameters. Then R is given in the question. So the torque will become 3611.23. Then self-locking. What is the value of self-locking? Self-locking, the equation will become, for the clockwise rotation, the value of F is equal to 0. So we already taken the moment equation. Then B1 into F2 minus B2 into F1 is equal to 0. That is, or B1 into F2 should less than or is equal to B2 into F1. Or we can write B1 by B2 less than or is equal to F1 by F2. F1 by F2 we know that it is e raised to mu theta, or B1 is equal to B1 by B2 is equal to e raised to mu theta. For a self-locking condition will become e raised to mu theta is equal to 3.164. That we already calculated. But if we substitute the value of B1 by B2, what is that value? 127 divided by 38. But that value will become 3.348. That is not less than the e raised to mu theta value. It is greater, or it is not equal. So self-locking will not occur. Then we can check for the counterclockwise direction. For the counterclockwise direction, again B1 into F1 minus B2 into F2 is equal to 0, because the value of F is equal to 0. If we substitute this equation like this, e raised to F theta should less than or equal to B2 by B1. What is the value? B2 by B1? B2 by B1 is equal to 0.299, or e raised to mu theta value is equal to 3.164. It is not lesser than 0.299. So self-locking will not occur. That is our condition. Okay, thank you.